So here is a 6-mark question asked in March 2018. If a 3 cross 3 matrix A is given with these details, find its inverse. Use the inverse of this matrix to solve the system of equations 2x minus 3y plus 5z is equal to 11, 3x plus 2y minus 4z is equal to minus 5, and x plus y minus 2z is equal to minus 3. So we need to first find the inverse of this matrix. For this, we need to check the determinant of the matrix, and it should not be equal to 0, right? So when you find the determinant of this matrix by expanding the rows, all that, you get minus 1, which is not equal to 0. Therefore, we can say A inverse exists. So the cofactors of this matrix has to be now found. Cofactors of A in detail we are going to find out. That is A11. If you expand, you get 0. A12. If you expand, you get 2. And A13. If you expand, you get 1. And A21, if you expand, you get minus 1. A22, if you expand, you get minus 9. And A23 will be minus 5. And A31 will be 2. And A32 will be 23. And A33 will be equal to 13. Then finding the adjoint of this matrix by taking the transpose of the cofactors, we get 0, minus 1, 2, 2, minus 9, 23, and 1, minus 5, 13. So this is the adjoint of this matrix. Therefore, inverse of this matrix will be given by 1 by determinant of this matrix into adjoint of the matrix, which will be given by, when you divide this entire matrix by minus 1, we know the determinant is minus 1. So we get 0, plus 1, minus 2, minus 2, plus 9, minus 23, and then minus 1, plus 5, and minus 30. So this is the inverse of the matrix. Now to solve the linear set of equations we can convert the unknown matrix, variable matrix X as 1 cross 3 matrix, which is X, Y, Z, and we can take the matrix B as the constant values on the right hand side in a 1 cross 3 matrix, 11, minus 5, and 3. And the system of equations can be written as the system of equation can be written as AX is equal to B. So then the value of X will be A inverse into B, and we have found A inverse already. We can use that directly. 0, 1, minus 2, and then minus 2, 9, minus 23, minus 1, 5, minus 13. All the values should be taken exactly as it is, or else we may end up in making mistakes. And then B will be 11, minus 5, 3. And when you multiply this, you get 3 cross 1 matrix. That is 0 into 11, 0, plus 1 into minus 5, plus minus plus 6, which will give us 1. And when you multiply the other values, this is minus 3 here. So it will become plus 1. And then the remaining, again, second row, first column, if you multiply, you get 2. And third row, first column, if you multiply, you get 3. So in this way, we have solved the equation, and individually value of x is equal to 1, value of y is equal to 2, and value of z is equal to 3. So we have solved this question for 6 marks. Coming to the marking scheme, we get here all these values. If you solve this correctly, you get 1 mark completely for all the correct values, and finding the determinant, you will get 1 mark, and finding the adjoint, you get 1 mark. Okay, and finding the inverse of this matrix, you get 1 mark. And representing the system of equation in the form of matrix multiplication, you will get 1 mark. And solving this product and getting the value of each of the unknowns, you will get 1 mark. So this is how you get 6 marks for this entire set. So now coming to the alternate question, which is again for 6 marks. Using elementary row transformations, find the inverse of the matrix, which is a 3x3 matrix again. So you have to solve this and find the inverse using elementary row operations. So using elementary row operations, we can say let A is equal to I into A, where I is the identity matrix of 3x3. Then the given matrix A can be written as 1, 2, 3, 2, 5, 7, minus 2, minus 4, minus 5. Yes, this is the 3x3 matrix, which is equal to the identity matrix of order 3x3, 1, 0, 0, 0, 1, 0, and 0, 0, 1 into A. Right? So now using the row operations, what we do is on the right hand side, using R2 changing to R2 minus 2 times R1, and also R3, that is row 3, will be changed to R3 plus 2R1. So the left hand side matrix remains as it is, 1, 2, 3, 2, 5, 7, minus 2, minus 4, minus 5, right, which will be equal to, by applying the row operations for the identity matrix, we get 1, 0, 0. Row 1 is not changed, whereas row 2 has been changed to minus 2, 1, 0, and 2, 0, 1 into A. Now using a row operation again, we are going to alter R1, that is row 1, will be changed to R1 minus 2R2. So what happens is, the matrix what we have obtained is 1, 0, 1, 0, 1, 1, 0, 0, 1, which will be equal to, now applying the row operations, above operations, 5, minus 2, 0, minus 2, 1, 0, and then 2, 0, 1, right? And further, one more time, we have to do the row operations. Then what will happen is, the operations are here. R1 is now changed to R1 minus R3. That is row 1 is changed to row 1 minus row 3. And row 2 is changed to row 2 minus row 3. What happens to this matrix is, now on the right hand side, it will become 1, 0, 0. So ultimate aim is to get the identity matrix on this side, right? That is why we are doing these row operations carefully. We get on the right hand side, we get 3 minus 2 -1, -4, 1, -1, and then 2, 0, 1. This entire thing multiplied with A. Therefore, A inverse will be, A is multiplied with the matrix and we're getting identity matrix. So A inverse, this is the A inverse matrix, which is 3, -2, -1, -4, 1, -1, and 2, 0, 1. This is the required inverse matrix which we obtained by using row operations. So coming to the marking scheme, it's a 6-mark question. So writing this equation will give you 0.5 marks, and writing this as it is will give you 0.5 marks, and doing this row operation and getting the next step will give you 1 mark, and this row operation will give you 1 mark, and this row operation will give you 1 mark, and identifying this and giving the right answer here will give you 2 marks. So totally you get 6 marks accordingly. And every data, every value here should be matching correctly. Then only you get the complete 6 marks for this question.